Hello everyone, today I'm going to be showing how to solve the integral of cosine of x over sine of x plus cosine of x dx. And I'm going to be showing a way that is lesser well known, and it includes adding another integral into our whole jumble here, and we're going to add that and subtract that from the original integral to make things a whole lot less complex. Let me show you what I mean. Let's have our first integral. Let I be the integral of cosine of x. I'm just copying down the original thing. Over sine of x plus cosine of x dx. And now we're going to add our second integral. And don't worry, this won't make things more complicated. In fact, it'll do the opposite. We're going to keep our denominator the same, sine of x plus cosine of x. And our numerator is just going to be sine of x. And you'll see why I did this in a second. Notice how if we add or subtract these two integrals together, the denominator doesn't change, and we're going to use this to our advantage. First, we have I plus j, which is just equal to the first integral, cosine of x over sine of x plus cosine of x, plus sine of x over sine of x plus cosine of x. And remember, when we're taking the sum of two integrals, we just take the sum of the inside and take the integral of that. So let me just erase this part, and we can start solving it right away. Notice how when you add cosine of x to sine of x, we get cosine of x plus sine of x. And the denominator is also sine of x plus cosine of x, so that would just equal 1. See how easy this is? 1 dx, which is just equal to x, and don't forget the constant of integration. Next, we have I minus j. And let me just write this out. It's going to be cosine of x, that's I, over sine of x plus cosine of x, and dx, and this time we're going to subtract the integral of sine of x over sine of x plus cosine of x dx. And as before, when we're taking the difference of two integrals, we just have to take the integral of the difference of the insides. So let's simplify this to this, and we can see that the numerator would be cosine of x minus sine of x. Cosine of x minus sine of x, and the denominator will always be the same, sine of x plus cosine of x dx. And we can solve this integral really easily with a u substitution. Let u be the denominator, which is sine of x plus cosine of x, and let du is just the derivative, which is the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And don't forget dx. Now we can find du in our integral really easily, as it's just the numerator. And we can find u really easily, as I said, it's just the denominator. So we can simplify everything to just the integral of 1 over u du, which we know is the natural log of the absolute value of u plus c. And we can substitute u with what we originally have here to finalize this. So it's equal to the natural log of the absolute value of sine of x plus cosine of x plus c. So now we have I plus j and I minus j. Let's combine everything together. We have I plus j here, and if you don't remember, I plus j is just equal to x plus c. Really easy stuff. X plus c, and I minus j is what we have right here. The natural log of sine of x plus cosine of x plus c. Now we're going to add these two equations up to eliminate j. We have I plus j plus I minus j, which is the second equation. And our first equation is x. We ignore the c for now, we just add it at the very end. Plus our second equation, natural log of sine of x plus cosine of x. And then we add c at the very end. Now notice how positive j cancels out with negative j. And we're left with 2i equals x plus natural log of sine x plus cosine of x plus c. And to get rid of and to isolate I on one side, all we have to do is divide both sides by 2. Remember, we don't do anything to the c as it's just the constant of integration. We just have to have it at the end. We divide 2 by both sides, the 2's cancels out, and we're left with I is equal to x plus the natural log of sine of x plus cosine of x over 2 plus c. And let me box that in so that we're all happy. So by adding and subtracting another integral to the original integral can be a very helpful trick if you want to if you see a way that will cleverly simplify things as what Jay did in this problem. Thank you, and I hope you have a nice day.